Is it visible?
Yes, sir, it is visible.
Yeah, so good morning to all of you. First of all, I thank you for the introduction. It's very nice that we have a program on forensic engineering, civil engineering particularly. And I think it's very important that we have a lot of infrastructure coming up, but at the same time, we have a lot of failures. And there is a need to understand these failures and so that there are no such issues later. And there are, the challenges are many in this. We'll discuss, that's what I want to say. I'm only talking about geotechnical engineering failures because the issue is that, I'm sure somebody must be covering. And actually, most of them, it's a lot of failures we have in civil engineering. And a lot of money is lost in public infrastructure and all of that, a lot of inconveniences. That is because of our own practices that we have. Nobody else to blame. It's only technical failures, nothing else. And since they're all technical failures, we have to really introspect why the practice is very bad. And you must have seen a lot of, even in Orissa, a lot of failures of highways, embankments, and many things. So, for example, I can give you this is an example of a slip of a drain. And then this is a landslide. Lot of mass subsidence. This is a railway embankment. The embankment gets washed away. And this is because of an earthquake. There is some failure. And actually, I've been seeing the construction of embankments is very poor in the country. The embankment, nobody thinks that it's an engineering structure. The maintenance of the embankments are so poor. And this is after some time it fades. Designs are not, the designs may be okay, but the construction and its practice of maintenance has not been okay. Even I was visiting one of the structures the other day, the compaction control is not there at all. There are no records of compaction control in the whole project. And but whereas we have every record, so proper specifications are not developed and implemented. How do you develop compaction specifications in the lab? How do you develop it, apply it in the field? And what are the requirements? Okay, you may have constructed a dam or an embankment. How do you protect it in the long run? Because once it is constructed, it should be lasting for about 50 years. So these two examples, this is an embankment failure apportionment, this is a railway embankment. So then this is a landslide that you see. This is also quite often. Many parts of India, they suffer landslides every year. But at the same time, the challenge is that we are not able to handle this. This is so whether there are no systematic studies on this, and also that there are a lot of issues that we have in landslide management. And actually, there are a lot of other countries that have learned lessons and then reduce this sort of damages. But in our country, there are so many engineering colleges, so many faculty coming up, but the introspection about engineering education, and also how do you avoid failures and how do you understand from failures is not there. And I think this course is very, very timely. And here you see a dump landfill, or actually you can call you don't have a proper landfills in the country. And though we have a lot of MTech, environmental engineering, MTech, environmental engineering, PhDs, lot of expertise is there in terms for the namesake. And you have pollution control board department, and I don't know what they do. You have a state government, central government, and all of this. But you see that the quality, I don't know, it's a direct reflection of the quality of civil engineering. And so this is a leachate here. This is a dump site. This is waste is stored. But you can see the pathetic condition in which they are being shown. Even I have to show it. Why? Because that's the reality. At the same time, see, like we have seen cases similar to this. If you go to, say, for example, some other country, this show that, yeah, this is a leachate, incoming leachate, and output is so good. It's as good as wastewater standards or anything else, or treatments are so good. Why? But here, what is happening? You just go to many of the dump sites, whether in Delhi, Bangalore, many places. Maybe I'm sure in Bhubaneswar as well. The quality of dump sites is very, very bad. They pollute atmosphere, both soil, water, air, and all of that. So in recognition of this, we have a committee called Forensic Geotechnical Engineering. Actually, that is started by it's Indian Geotechnical Society. We had one of the first persons, Dr. VVS Rao, who wanted this, because the failures continue to happen, but what do you learn from them? So we discussed with that. And then after that, I became the secretary of that the particular committee. Then we have been working on it, and we have been conducting a lot of programs. We also came up with a book. Okay. So what do you mean by this forensic engineering? Okay, so the forensic engineering is to the forum or the marketplace belonging to courts of law pertaining to, or the issue is that like if it is something is which is public, like, so people try to show some noise. If they want to talk, they can talk. I can keep quiet. Okay. Yeah. Okay, thank you. So the thing is that the forensic is something that is more connected with the the public. So they try to discuss it in the court of law, and it has a legal framework, and there could be discussions on what went wrong, why is it, and who is responsible. So that is called forensics or forensic engineering. So the forensic engineering is nothing but engineering connected with assisting the legal system with fact finding. Okay, because the legal system alone itself cannot identify what went wrong, because it's a technical work. So the engineers have to help with them to understand what is this failure, why it has failed, what is the engineering failure here. That's a general thing, but AIC has been quite proactive, because of this, that they say that the forensic engineering is application of engineering principles to the investigation of failures or performance problems. So AIC has been in the forefront of forensic engineering. They are one of the first persons in the world to start something on forensic thing. Okay. The forensic geoengineering involves scientific and legalistic and deductions to detect the cause as well as the process of distress of a failure in a structure, which are attributed to geotechnical engineering. What is this? Geotechnical. Why geotechnical comes? Essentially that it can be forensic highway engineering, because highways are very bad, traffic jams are there, and we have what should be done to see that that's a, so you can have forensic structural engineering, forensic environmental engineering. All of this is there because we have a lot of soil contamination in the country, or water contamination, air contamination. So a lot of issues we have, but here I'm only talking about forensic geotechnical engineering. So what is the difference between forensic geotechnical engineering and what is the normal thing that we do? It's called, you can say, design engineering or design and construction engineering, whatever you can call it. So here the design, we do the design, and the normal engineering, we design and construct. And what do? You try to find out, at least in geotechnical engineering, you try to find out the, say for example, bearing capacity of a foundation, then do some lab tests, field tests, get some parameters and all of that. So you design the foundation, you construct the foundation, or it can be a dam, anything else, you do that, and apply some standard method of calculation of factor of safety and the stability, deformation, and all of that. So that's what we do, and finally say that the structure is safe from design point of view, and the construction also is done as per some guidelines. You have some kind, because design has to be translated into actual construction, and the design point of view was that uh, the design may be all right, but construction has very important. But ultimately it could fail. So why does it fail? Then you have to understand that that is called forensic engineering. And here the aim is to understand why it failed. Like, so investigation you do, then try to evaluate. Maybe you can check the evaluation in terms of the calculations, in terms of the parameters involved. So maybe in terms of the bearing capacity, say C5 gamma, or settlements, E value or whatever. Then you can, the aim here is to fix up liability assessment. Who is the person who did this mistake? Is it a designer mistake? Is it a construction mistake? Whether he did not do proper compaction, whether the soil itself is tested at all. Most of the times in India, testing itself is not done properly, and it leads to problem. Then method, what is the method? Survey of distress, like what is the order of distress it has happened? Did it move by 1 meter, 2 meters, or the collapse is complete, or what happened? Is it only a crack? How many number of cracks? So we should do that. So we may try to do a standard field test. You may do a model test. Model test means that, say for example, you construct a footing and or a dam or anything in a small dam or small footing, and try to understand the mechanics of foundation design. Then you may even do a simulated special test, because the issue is that here we are trying to simulate what are all the conditions. So for example, you have designed a certain drainage design is done, but the drainage design is not completely satisfactory and it led to failure of the structure. So whether the testing is done as per the expected rainfall, no. Then that has to be verified by using a simulated rainfall test, like it is possible. People do it. Then laboratory tests with simulated field parameters. Sometimes we get the parameters in a very standard way, like you don't even do a proper testing, but you have what is called stress path testing in geotechnical engineering. Like, try to construct the stress path which is followed. Like, you take a soil element and apply the load, then you observe it and observe its pore pressures and all of that, and try to understand the conditions that lead to failure. So that is called laboratory test with field simulated parameters. Like, say for example, we call them as undrained testing, drain testing. Then we'll try to see when the testing, when the conditions lead to failure. Failure is nothing but reaching the critical state line. So people do that both in earthquakes and even in conventional foundation engineering. But unfortunately, such things are not taught well in actual practice. And that's a problem. That's what whenever we see in conditions in India, the failures are utterly lack of this understanding. Am I audible? Hello?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So keep your mobiles off for some time. I know most of you will be 50% on mobile, 50% one year here, 1 year there. Is it not? So let us just listen to that. Let us not make a forensic lecture a failure. Okay. So what is that we do? Is that we try to analyze what is called a back analysis. You try to do what are the why it failed. So you try to calculate the parameters that are close to failure. Like the factor of safety is 1, is called less than 1 is failure. So we try to calculate the factors that lead to that and verify if they are there in the site. That means that, say for example, if the compaction is not good, then there will be a lot of seepage also. It can lead to failure. So check for actual limit conditions. Try to take it to the limit failure conditions. Like, try to understand the conditions under which it can fail. Verify the validity of the design that was done. Then model with actual experience. Try to superimpose on that what has actually happened in the field. Then develop a discuss hypothesis. What are all the things that have happened? Why do you think that there is a failure here? So try to come up with some sort of failure. So, for example, I will maybe discussing later that okay, there was a rainfall that occurred because of this. Already, that is in a state of failure, close to failure. But the rain came and then completely got washed away. It's like that. So compare with previous experience. Of course, this is very important. See, maybe if you have to find out, because see, some of these failures are quite common in most of the countries. They're not unique to your own conditions. And so if you have some literature and all of that, then you'll understand why the failures have occurred. And you can take care. But I don't think we should learn from our own experience of failures. So it's better to always learn from the failures from elsewhere, so that we don't have to have the infrastructure failures and all of that. So what is the result? You just try to say that what went wrong? Like, was that okay? Design was okay, but was the construction not satisfactory? Why did it happen? Okay, why did it happen? Okay, and then when? Is it what conditions? Is it the night or day, or what was the sequence? That's what you must have done. Crime investigation, right? Crime investigation and movies we have seen, and by whom? Who is actually responsible? Is it that is it whose fault is that? So here so that is what we would like to look at it, so that we understand that such things are not repeating. So there are definitions of failure, like Leonard is the first man, one of the persons who gave a lecture on investigation of failures. Based on his work only, he gave it is called the Kazage lecture. 1982, he gave a lecture, and then he even suggested the formation of a group of members, like a forensic engineering committee in US, and he has been responsible for the So this is some difference that we expect, but so we try to then warn them that, okay, let us not do that next time. So you try to do that. So the failure is defined as an acceptable difference between expected and observed. So then next thing is that the factors of failure affecting the safety involves okay. That we have seen a lot of failures in like collapse, complete failure, whether it's a landslide, whether it's a road failure, whether it's embankment failure. We have seen this. Okay. Functional failure involves a compromise of intended usage of structure or facility. So sometimes we have seen that there's a pothole ridden road, and we are happy with that. But because they still people drive, but then so there's actually the functional failure of the road is there here. Serviceability, it's not actually serviceable, but people have been using. So the serviceability requirements, riding comfort, there are so many things in payments. So that needs to be considered in trying to evaluate the failure. Then there are a lot of other failures, like the cost failures. The cost could be maybe 1,000 crores. Now after 6 months it becomes 200, much higher, 10%, 20% increase. All of that, or even intended use. Actually, we have seen many times in India that they do something but it's not used, like complete misuse of the actual purpose. So people have been tabulating the type of failures and the type of what are the reasons. One is called design deficiencies. I've seen a lot of failures on design, like unfortunately what happens that the design is based on certain parameters, okay, and certain fundamental principles, like you assume some mechanics to say, for example, there is a slope failure, a slip circle failure, but there is no slip circle failure at all. It may be a planar failure because the sand is somewhat loose. And so slowly that loose sand comes out. So the design failure is possible. Okay, that is high. Then site investigations, actually it is most of the time in India, geotechnical investigations are very, very pathetic. I don't know how many people are there with, uh, in this course, but you insist on good geotechnical investigation, whoever it is, it doesn't matter, because you don't get properly. And not only that, the soil is quite complex, not like steel and concrete, where you can test them quite repeatedly and get some parameters of or whatever yield modulus or compass system. It is very, very tricky in soils, because it has a, it's not a continuum like steel and concrete. It is stated as elastic in concrete and steel, but in soils, because of the presence of pores, if it is a porosity 30%, 20%, it makes a lot of difference. And the pore water pressure is there in the pores. You don't have such problems in soils. So the selection of design parameters is something very, very important. Like even yesterday I was seeing, they don't know what they're doing. There are a lot of soil investigation companies. They do investigation and the parameters are wrong. Can we actually allow these sort of things? Like there is a corona testing nowadays going on, but can you accept a wrong diagnosis of parameters? No. Same thing, seriousness is not there. Okay, so that is a one problem. Then design methods, like I mentioned, very important. Calculation of failure mechanism. See, the design methods comes from assuming what type of failure can occur, and using a failure mechanism and to calculate the failure, make failure calculations, we have to come up with some equations. If the mechanism itself is wrongly taken, then you will not do that. So, for example, combined bending moment, the forces acting due to moments, vertical forces and horizontal forces. We try to impose the equilibrium from moments of vertical forces and horizontal forces. And if it is not considered properly in any situation, things can be totally wrong. So that's what it is. And there could be miscellaneous, many construction errors are many, like because there is a lot of the gaps between design and construction. Then material defects, like what type of material you have, whether it is same as specified. Maintenance are many, and there are a lot of things. Like we see that the maintenance is a problem in India, and the above numbers, whatever you get 30, 46, 21, I gave, it is some random numbers. It can be totally together some 100. But depending on your place, maybe you can have a BTech student and MTech student, ask them to come up with a survey like this, that how many failures are there, whether it can be a road. And in fact, in my opinion, sometimes the specifications also the government are also not good. Like if you look at government affiliate specifications on highways, if you look at specifications on landfills, they're not so precise that lead to problems. Like, say, for example, they don't tell you completely what should be done. I can give the example of highways. Like the drainage design is not okay. I can give it in writing that the drainage design one should really understand. And I'm sure that you have a lot of highway engineers here. Why did anybody investigate why there is a washout of a road when there is a rain? Nobody bothered, right? We're very happy. People are ready to make some budgets next time. 10,000 crores, 5,000 crores, some numbers. But investigations costs much less cost. But in future, they save a lot of money. Like I can give an example. In Karnataka, there are a lot of landslides about 2 years back, and the engineers immediately came up with a budget telling that there is a loss of 10,000 crores or something because of landslides. I was asking them, how did you calculate? I mean, of course, they have some ways of calculation. Then I came up with a proposal that you try to do a proper investigation of the whole landslides, and it could cost you 1 crore or 1 or 2 crores, because the area is not small. It's a district, and to spend on the whole district 1 crore is I mean, when you want to project 10,000 as the loss, 1 crore is actually, it helps you in the future. You are trying to do a proper investigation of the whole landslide prone areas and the stability and all of the, but nobody was ready. So next year also again landslides occurred. It keeps on happening. I'm sure that you're all very many people are aware of this. One more thing, actually, I understand that you have a test in this course, and maybe you should think of some questions so far on what I covered, like what type of errors you can have in forensic engineering, and what is the difference between actual engineering and forensic engineering. Can a normal engineer become a forensic engineer? Because I have seen the design. I have seen sometimes design. I have met some design engineers. They don't know very good design itself. They don't know well. Then they went to construction, because construction you can get a lot of money. Construction margins are higher. Maybe designs, the margins are very, very low. So he was neither good in construction or design, but he had so a lot of problems were there. I have seen some of the. So what I meant was that design engineering is different, forensic engineering is different. Okay, and then it needs experienced persons and a lot of fundamental understanding of the subject itself. Then you can do a forensic analysis. Otherwise, nowadays with all the software generated designs, and since you don't have a feel, one will not have feel for the actual mechanic, and you can't visualize completely what can go wrong, then it could be difficult. So that's an issue. So as a part of the forensic geotechnical engineering, we suggested some steps. One is that the moment a failure occurs, you have to collect evidence. Like it's like crime investigation, right? Without evidence, you can't prove it, right? So you have to go and collect the data. So for example, what type of failure surface is there? Why? How the failure occurred? Is it only a settlement? All the data that connected with the failure. Okay. Okay. Yeah. Then the thing was that the characterize distress. What is the character? How is the distress characterized? Say, for example, there are cracks. Is it a longitudinal cracks, vertical cracks, horizontal? So there is a road collapse. So when the embankment is there, there will be a lot of distress on the road also. So what happened to the roads? So you can characterize the complete distress. Once you have all of this information, like each of them, you can prepare a checklist actually. Okay, depending on the problem. Then design review. So design review, how do you do it? You just look at what are the designs that they have, like what is the design method they have used, and with the use, like I've seen some places, this is an embankment case, they didn't have any design document, but then they constructed 10 meter high embankment, no compaction control, and there is a lot of seepage already. So, and then they're all MTech and chief engineers are there. I'm worried. I mean, they're also worried. The moment I told them there is a danger, it looks fine, but there's a problem, nobody verified. Then we are trying to check if there is I asked them whether you have any design. They said no, because they for them, embankment construction is like dumping some soil and then rolling something here and there. No soil characterization, no testing, nothing is there. So this is what I've seen in some places. So then specifications, like what are the specifications for compaction? What are the standards you have to follow? Are the standards good enough? Like you can look at different standards, like IRC standards, IS standards, like the even international standards. So if the standards are not good, it is difficult. I'll give an example that the bridge score is a problem in India. Score of the bridges, like because of the scoring and river action, there is a lot of the foundations get exposed, and the bridge foundations are exposed, and there is a lot of failures. But nobody compiled them. And not only that, you have an IS code, you have an IRC code, they have a different ways of talking. And these codes, whatever we follow, nobody in the world has similar understanding. And you look at Australia code, it is different. You look at American code, it is different. But the same score, water, the soil under the influence of water is getting removed. And how do you calculate the exposed depth of foundation? Depending on type of foundation is a question. For that, there is so much of confusion. But not only that, nobody measures the velocity of the stream in the bridge foundation. Suppose we have a bridge. Should we not find out, because there is a flowing bridge under that, should we not have statistics of erosion and likely erosion or likely understanding? Because once one of the piers or abutments fails, complete failure is there. It's not done. So what I want to say is that our standards and specifications need to be thoroughly reviewed. And if it is to be international, you should go for that, because we need to improve our standards. Then use of diagnostic tests, like there will be some laboratory tests and field tests. Yeah. Then, say for example, the diagnostic tests, like, so you have a lot of laboratory tests and field tests, say for example, in soil mechanics, you have track cell testing and all of that, and field test, SPT, CPT, and all of that. And even in any subject, you have the same thing. So you have to try to understand the data from the field and test it in the lab. That's important. To assess the design parameters, right? Then role of instrumentation and sensor-based technologies for observations. Nowadays, there's a lot of instrumentation that is done, and a lot of companies are also there. People can have a lot of startups on this. And so I just mentioned about the score in the dam. But in fact, I was just looking at the guidelines. They don't have proper monitoring methods, like the bridge health monitoring. It has become very important. Health of the bridge has to be monitored. Like our BP sugar is monitored regularly every 1 month or something. So there is a monitoring system established, and it's only about perception. Only we believe in perceptions rather than actual calculations. That's not correct. So we have to really look at proper instrumentation and sensor-based technologies. Then you have to have a failure hypothesis formulation, like what conditions led to failure? Like, was there any sudden velocity of the water in that? I don't know, somebody must have heard. In Tamil Nadu, there are a lot of flooding that took place because some engineers said, no, you have to remove the gates of the dams. All the excess water flew into so many other places. It caused so much of damages that, unpredictable. People who didn't expect that this will happen, they're all buried. Houses have collapsed. It's like that. See, the thing is that, since we don't measure or monitor anything, and we take some decisions which are not really, we don't understand properly the impact of those decisions, it will lead to problems. So the failure hypothesis is very, very important. Like what could happen, what has happened here, and all of that. Then back analysis. Okay, you have a failure hypothesis. How closely it represents what is observed. You have to prove it. So then risk and consequence analysis is something that how many people are exposed to particular risk, and risk is in terms of the number of people exposed, the money that we spent on this, like it could be a few millions of crores or something, whatever, right? How much, if you don't do a failure analysis properly, then the risk continues to happen. Then the risk associated in terms of the loss of human life and loss of money is quite high. That is called risk. and consequences also. It has cascading effect in most of the cases. So that way, the good engineering is to be done. Our objective is as teachers, you should train engineers. You should not train teachers, because teachers are there, but being engineering college teachers, you should train engineers, and for which, first of all, you should be a good engineer, and you should practice engineering, and preach good engineering, right? But if you just talk on only from textbooks and give some concepts, simple concepts that will not be even difficult to comprehend in the field. Sometimes because in the field the things are much more complicated, right? Important. So that's called risk and consequence analysis. Then technical shortcomings. Actually, this is a very interesting thing that when you do a design, then you have made some assumptions. In the construction, the construction has to be as close to what you assumed in design. Like I can give a simple example of, say, for example, if compaction is good, so the cohesion friction properties will be good. But if the compaction itself is not good, and if seepage is allowed to get in, like, say, for example, the design is as per, they have not considered the water surface phreatic line. Okay, but your dam has water on one side. They have not put a geomembrane. So which means that though the suggestion was to put a geomembrane, somebody said geomembrane is very expensive, let us not do it. Let us construct as it is. So there is a lot of seepage, and with the result that it got washed away. So what is the shortcoming here? It's not the design, it's about the shortcoming of the construction process, that they are not understood. The documents, the construction documents are not properly understood, and even there is no appreciation of what can happen. So inspections are necessary, and we have seen that the inspection is something very poorly done. Like the inspection records. Inspection means inspection record, but we have seen rarely proper inspection records. We don't teach them how to maintain inspection records. Myself, I've seen that it's all vaguely. It should be very clear. Like we got a BP sugar result. So the consequences is that if the inspection is not good, it is a problem. There is a nice quotation somebody was telling: if you get what you inspect and you don't get what you expect, because if you expect something without inspecting, you will not get it, right? It's clear. Then liability assessment, recommendations for practice. Liability assessment is that how much is a loss, right? Then recommendations for practice. So maybe if you want to ask something, you can ask this question here. What are the suggested steps? Yeah, this cause of failure I've seen. Yeah. What I will just tell you about is landslides. Then some studies with landslides in Kerala, Kodagu, Maharashtra. Then retaining wall failure, RE wall failures. What is the you learn from failures? Natural versus human-induced failures. Need for a good organization. So like PWDs are there, but they continue to their design cells are very poor, and it's very pathetic. So we have, what is the engineering education that we should do? It's good that the course is being conducted. This is one good course. And what is this landslides? We know that the many places in India are landslide prone. So for example, Northeast, and Northeast is there, then the north side, and then the Southwest, particularly the Maharashtra, Kerala, Karnataka, all of that. So there are a lot of landslides, and maybe August 2018, it's supposed to be 100-year rainfall. It had a lot of landslides, and it's quite damages was quite extensive. I talk about one old landslide. This is in Maharashtra state, and length of the slide is about 500 meters. The width is about more than nearly 100 meters. Landslide 44,000 meters. Volume is quite high. Yeah, it just came like this, completely devastated the complete village here. Okay, and you can see that the brick houses, mud houses. You can see, because they're all people living in next to the landslide. Though they were not supposed to be there, but they were there because on the landslide they were growing. They didn't know that it's landslide, so they were putting a lot of paddy there, and they were living next to them. Though they were told not to be there. So the landslide occurred early in the morning when the residents were asleep, morning 7 or 8 o'clock, and when the landslide was noticed by bus driver who drove the area and saw that the village has been overrun with mud and earth. Complete area, all these houses. This is actually so many houses you can see here, right from top to bottom. All got washed away completely. None of these houses were there when even I visited the site. And 150 or 160 people died, right, small village. And so what was the reason? It's a rainfall in this landslide. Continuous rainfall for the previous week and heavy rainfall for 3 consecutive days, most likely triggering factor for failure. There are no seismic events because of, see what happens, why we should know this is that sometimes in places like Sikkim and Northeast, you'll have rainfall as well as earthquakes. So you have to make a record that there are no seismic event there. Rainfalls continued after landslide, making the operations difficult because that leads to more number of deaths, is it not? So like one must look at, if you want to look at consequence analysis, you have to find out all the details. So I have shown some steps here. I picked up a few of them. And trying to explain the collection of data, distress characterization, development of failure hypothesis, failure level test analysis. Okay, we thought we'll do up to this, and because that's so this we can do a lot completely. All the 7 steps can be done, but it is quite expensive, and it is like some professor sitting in the office cannot be doing, but it should be done at a government level, with more complete involvement by the people involved, like IAS officers, and district administration, all that. Right? If you want to do a consequence analysis and data, actually most of the time what happens is the failure occurs, somebody goes and gives a report, and after that there will be a big proposal next time to do something else, right? So failures, we don't learn from failures. So here what is the scope is assist in mitigating landslides in the future, provides more rational basis for selection of proper slope remedial measures, provides systematic and rigorous processes to formalize slope engineering practice and enhance slope management. This is the scope that we are trying to do here. So what we did was that we just collected the data from the site, like essentially the slope geometry and all that. Okay, like this is a slope profile, like paddy fields, paddy field, but the houses are in between. Okay, whatever you saw in the particular photo, you have all these houses. There is a road here, so you have a bus stand here that you saw in photos, all of that. So then you have a nalla here, so it just completely failed. So people are supposed to be somewhere. Then they thought that this area is good for agriculture. They came here. They also wanted next to the paddy fields, but they were asked to not to be there. But the choice is theirs. So it has happened. So the rainfall event data was collected. There was the rains come from July. It was there for a very long time. But in the second rainfall, it's quite intense, and you can see the amount of rain, and you should be able to correct. But in some countries, they really plot those results, like people from water resource background or hydraulic background, or even general background, they can always plot the results and then predict and do certain things. Of course, we do it intuitively, then but there is a need to do calculations better because these are all some variations in water content and moisture, and that may affect slope stability. So the distress characterization was that in maybe 10 years before, there was some distress, and villages were also villages. There was a village. There was a problem, but there was indication of landslides. Okay, villages were evacuated to adjacent area and housed in specially erected shelters, but they returned to Malin village, which led to the large-scale casualties. Okay, so this is a landslide 7 meters thick. Actually, the failure hypothesis was that the heavy rainfall led to the problem. But then, if you want to analyze what is that, so the rainfall must have decreased in submersion below a threshold value required to maintain equilibrium of the soil. So you have the soil properties here. You have the Van Genneken parameters. In fact, Van Genneken parameters will give you the soil characteristic curves. Soil water characteristic curves are very, very important for understanding the rainfall in the landslides. So Van Genneken parameters is one way of characterizing the soil water characteristic curve. So we got some test results like all of these parameters and all of that. So we did back analysis. The motivation for the back analysis is that you have to find out the set of parameters that led to failure. And we also did what is called probabilistic back analysis. Why? Because there could be many combinations of parameters that can lead to instability. That's what we want. So we did a numeric analysis, probabilistic analysis. It's called inverse analysis. Like, given that there is something wrong, try to understand what is wrong is called inverse analysis, right? So this is what we just mentioned. This is the Van Genneken equation formula. And so this is the type of failure that has happened. So we are looking at first event profiles, second event profiles, saturation, pore pressures. You can see that in the second thing, the saturation is close to saturation was quite high. Say, for example, here it's 0.95. It's close to 1. So in that 7 meters debris, okay. And pore pressure buildup is here. So there is also some understanding. So what we said that the events of low intensity and long duration may not be harmful to the slope because there is not drainage there. But if you have high intensity and short duration, there is no problem. There is a problem of drainage, and pore pressures do develop, and the effective stress of the soil comes down, and there is a reduction in the factor of safety. Right? So we did all of that analysis. These are all the parameters of the soils, like input parameters, cohesion, friction, suction. Suction is supposed to be negative pore pressure. Because the negative pore pressure, it becomes positive, then there is a problem. So we did this sort of analysis, and we find that there is a need to evolve a comprehensive protective and predictive management strategies for disasters. This is valid everywhere. But we seem to everywhere. Actually, there was no other. I have not seen many other back analysis and landslides work later in India. Actually, ours is one of the existing ones. And if you want to do a proper work, it's important, like improper land use planning, root slope management, deforestation. All of these are also responsible. That's more into planning of the hilly areas it comes. And if you don't plan well, you will have problems. And even early warnings, then they had an opportunity to put it, but nobody bothered. And one can monitor inclinations, deformations, pore pressures, particularly when people are staying close to them. Actually, the one way is that the rainfall. What happens is that certain rainfall causes this landslide. Not all rainfalls, right? So there is a threshold rainfall. So we have to find out relationship between rainfall and landslide occurrence. Because rainfall is a load on the system, and if you don't provide proper drainage, then landslide occurs. So the rainfall is something that we should be able to quantify. That's why the design is a matter of providing proper capacity to the loads that are coming, right? So in fact, people have done a lot of studies on this. Like if the duration of the rainfall is more than 1 week or 2 weeks or 3 weeks or 4 or 5, 6 weeks, or if the cumulative rainfall, if you measure, like in a particular area, is it 200 mm, 300 mm measure. So if you plot in a landslide prone area, they have plotted a line which say that above this line, they had landslides. It's like, so for example, here for 1 week, if the rainfall total duration is, say, for example, 200 mm, definitely landslide would occur in that area. That's what it means. So that is called Keynes threshold. This is called, this line, what I mentioned was called a threshold. And if you know that there is a lot of rain, then definitely you can say that landslides are there. And of course, this is known in a given locality, which means that they have to be fine tuning. We did that type of analysis here. Like this is Keynes global threshold. This is a red line. This is a dotted line in this. Actually, we took the data of the particular. This is actually in a particular state. Sorry, Arunachal Pradesh thing. That we also got this equation, and then we have 3 landslide events here. Okay, so it clearly shows that the actual threshold is somewhat different than what the general thing gives. So you can see that the equations are completely different. This is Crane's list I equal to 14.82 to the power 0.39, whereas in this case it's 43.5 like this. So what I want to say is that use of some other formula which may be not correct, maybe not valid, because it depends on the slope geometry, type of soil, and all of that. But still, it is possible to come up with some sort of relationship between the rainfall intensity and the duration, mm per day, and the duration, this type of equations. So you can see that here, the line is here, and these 3 are above, which means that landslide occurred. Had you used this same thing, it only means the Crane's one, this would have occurred. That's what it means. Okay, that is what the importance of threshold levels and all of that. Okay. Okay, so this is another one in Kodagu, again, one of the popular destinations in Karnataka. Okay, people love to go to the Western Ghats here. Again, a lot of landslides. There are all typical examples, and again, very, very expensive. So what we're trying to do is that, again, we're trying to look at a district level. What you saw just now was about one location, but people have to do at district level. See, the thing is that suppose you have a district in Himachal or which is a hilly area, the district collector has to be, all people should be a little more sensitive to those things and come up with the models and calculation procedures and even help rehabilitation measures and all of that, because people get, they suffer because of this. So we did some sort of analysis based on that, like this is for one of the districts in the year 2013, you have a 2018 landslides. Okay. So we are trying to see that you had only 3 landslides in a particular area in 2013. But then 2018, I just mentioned that the rainfall is very, very high. So you have more landslides. So we use this type of data for calibration, because every year, say for example, 20, 30 years, if you have data, like, okay, this year, this much of rainfall, this year, this much of rainfall, how many landslides are in the same area? No, we are not really, it's somewhat empirical, but at the same time, good enough for planning. Okay, like in a district, which is prone to landslides. So for example, in any district in north, like Uttaranchal or Badrinath or something, You can do this type of analysis, and it gives you a lot of information. We are calculating the factor of safety using the Tigris method. There's a method for that. The other important thing that I want to say would be that when the 2018 problems came, they have in years geotechnical extreme events reconnaissance group. Okay, the moment this problem came in Kerala, within 1 week, 3 days, they all came and did the survey of the whole area, and they prepared a report. The report took maybe 15 days. That's it. Like, it's amazing. You can see the date is at 17/10/2018 in October. Okay, the event occurred in August, and the report was completed within 2 months. You know, it gives you so much information about what has happened there, because they have to cover at least 5-6 districts. Okay. But we don't do this type of studies in India, neither government, we don't know. But see, these are from years, but it's available in public domain. You and me can download. Whereas we don't know anything, even if you go to collector or any office, you will not know anything. That's a pity here, right? And you can see that it's all supported by universities, and I'm sure the National Science Foundation and extreme events. So the DST, we have NSF equivalent of DST in Government of India. We have so many universities here in India, but we have never done this, right? Like that is we didn't come up with any report. So the that particular report was very good, and because of the rainfall is 140% more than the normal. That's what they say. And it led to 483 people dying and all of that. The GEAR study was carried out from 5 days they were here, okay, in Kerala. 3 districts they covered and completed the report. Okay, the report shows the number of geotechnical failures such as landslide, buildings, and all that. It's very interesting. So, but we have never seen this type of reports for though we have so many things happening regularly, right? The problem that we have is that the connection, the efforts that we have are all disconnected. You know, I don't know whether they're efforts, because for the same slide, I know 10 people who will visit, that 10 people are not connected. Like, you know, you'll have a team from Government of India, you will have a team from some other ministry, you will have some other team from local activists, you will have some picnic people, all sorts of things. But nothing will get connected, and the problem stays there. Then the sporadic attempts is something same, you know. So there is a need to have systematic efforts by the local governments as well as local geotechnical communities to improve understanding practice. Which means, see, the one I want to tell you that geotechnical engineering is not like, you know, it's not connected with hydraulics or something. People have another problem in civil engineering, that there is no dialogue between a geotechnical engineer or a structural engineer or a water resource engineer or an environmental engineer. But failures continue to happen, so that is not correct. So people should really work together. This is another thing, that we have an embankment, railway embankment. No, it's about 800 meters thing, and we did all of this evidence, distance design review, all of this we did. Okay, so there's a railway line that goes here. There's a highway line. This bridge, railway line was all right, but there's an overbridge here. So 800 meters length, like, yeah, you can see from 772, about 700 meters length. It completely collapsed. Like, you know, if you go to the bridge, it will be a lot of tilting, pavement is gone, and all of that, you know, like this, you know. Though this is supposed to be like, you know, you can see overturning of the wall. If you measure the overturning, actually a very crude way of measurement here, it's about 800 mm. It's like, we studied about returning failure, overturning failure in subject, but you can see all of them here. So we measured the SPT values of the materials and all that. We find that the compaction is not good. We monitored the movements. Movements are quite alarming on all the four sides, west side, the east side, south side, all of that. The settlement of the road was about 200 mm, because it sank, road structure sank, the vertical settlements. So we did analysis, and we find that it failed in this manner, which is actually close to what we observed in the field. Like vertical settlement, 342 is what we saw in the model, but field 327. So reasonable agreement is there, at least in terms of the MM. And we clearly see that the factors of safety are quite low. So actually what we do is that, funny thing, yeah, it is not here, yeah. Let me just highlight. We do all design checks actually, what overturning check, stability, overturning, sliding, bearing capacity. But in this case, it says the failure by sliding factor of safety was less, but it didn't tell anything properly. It didn't tell about the actual failure mechanism. What has happened is that there is a little bit of overturning. Though overturning factor of safety was good, but it didn't tell us about overturning. But actually, what happened was overturning. So what I meant was that our design procedures have not been very, we don't check it properly. We just casually do that, and the soil compaction was not good. All of this was there. One important thing was that it was about 8 crores was the cost of construction, and after construction it failed immediately. Then for 2-3 years nobody went that side because it is people were worried that something else will happen. It's actually a bypass road of 700, but then somebody said, can it be repaired? Why? Because it is you can't demolish it because money was spent. A lot of money was spent, and if you demolish the 8 crores, who is responsible for the 8 crores? So somebody was looking for a repair work, and somehow I stepped in, and we did repair of the whole thing. And of course, this is not a part of this presentation. It was we normally that same whatever conventional thinking was that you remove the demolish the structure and reconstruct. It should have costed 8 crores of demolition. You don't know what to do, where to do, and because it's failed, road failed, everything is failed there. But then, so the problem was that then we could repair it in 3.5 to 4 crores. Okay, so that way it was quite a very nice one. So it is now working. So as I said, the failure was essentially a design failure here. Backfill compaction was not satisfactory. Use of proper design analysis methods required for general practice and profession. Actually, as I said, here the other problem that was that DPR, they prepared DPR, and whatever is the design that is there in DPR was used for construction, and no detailed design was there anytime. Because I asked them, why didn't you do a detailed design? This is that they didn't have time because they were very busy with land acquisition, like that. So that way, if the government is busy like that, engineers are not serious, then it's a problem. But what held finally, what we was that the same engineers have to be a part of the rehabilitation because nobody was ready to come and do the rehabilitation. So we had to guide them. They did that, and it was very good. And it was innovative, and it led to confidence building among engineers, because you can repair what you did spoil. It's great. RE walls are very standard in India, but the failure rate is very high. Quality of construction is so bad. There is a 1% failure in Indian scenario, like out of the 100 walls, one will fail, which is actually very high. But even the worldwide also same thing. If you look at the worldwide statistics, it's not very different. Maybe in India it is more. Maybe you can say a little more than what they have, because we have many contractors doing the same work without knowing what they do. There are 20 contractors, but there are only out of them 4 or 5 are good, but others are all duplicates. We have seen them. That's a problem. So it goes for failure. So this type of failure So you're all very active in WhatsApp circulating failures. I'm sure you think that you're serving the profession by circulating WhatsApp messages on failures. But it's good, but we should look at failures and understand. We have a lot of surrounding for society, all of that. So here we have seen again a big flyover just 3 years back. It failed like this. All this came like a pack of cards. So we had to rehabilitate like this. Let's see that. What I meant was again, it is a design failure. It's a connection failure. Actually, it needs 1 hour lecture on this. What is the problem with RE walls? Which actually I'm giving tomorrow to somebody. Okay. Yeah, this another failure. This is quite common. I mean, you kindly send some information if some of you have with reasons for failure, what you understand. I welcome it. So some of the failures in RE walls are because of the lack of understanding of design principles in quality control. Like design, they don't understand the design principles. Poor connection design, poor backfill quality, the complex is not good, inadequate drainage provisions, and inadequate quality control. Then common communication gaps between engineers, contractors, and material suppliers. The engineers, government engineers, they are not very familiar with the design. Contractors also, they supply. We have some people who supply geogrids and all the material, but after that, they don't take any responsibility. Contractors who do not know, who want to cut corners everywhere, they're there, like they don't want to do proper compaction. They don't want to do good material, so they want to cut everywhere, right? So that way it leads to whereas the design is very precise. Everything has to be very good. You assume those things, but if they're with the gaps, communication gaps, then it should not happen. So that's one thing. So what are the issues here? Is that I just mentioned that the analysis of failures and learning from failures need to form an important concept of component of engineering. Courses can be offered for students and professionals. Of course, we are doing it now. The advantage is that it leads to better codal design analysis procedures, better codal provisions. It saves a lot of money and accountability also. There is a need to have an association of forensic engineers in each country who can facilitate failure information, analyze data, and provide technical opinion to support judgments. Like, say, for example, you have Institution of Engineers in India. You have Institute of Civil Engineers. There's so many organizations. None of these professional organizations, including IGS, we are not doing we are not doing any forensic engineering, which I think is, though I have been pushing how we have been working on it. But even each of the, so for example, Indian Roads Congress, why the roads are bad? Nobody answers, right? So why these things is all required is that you need to interact with finally what is happening. The judicial system will punish the engineers system. Like I know some judges, they don't have a good knowledge, and if they don't have good knowledge, the judgment will be wrong. So here, our engineering personnel should be able to understand what is required for correct judging. If it is not properly given, then it's a problem, right? So you have a chance to become a good forensic engineer. You can be a BA, LLB, a lawyer courses, and be a forensic engineer. But because you will be a good of both legal, provisions as well as okay. I was also suggesting the courses here, like particularly it is possible in every subject that, but I'm talking only about forensic geotechnical engineering. There are a lot of lectures, top level lectures, because luckily now we have everything online and you have access to a lot of good material. So there are a lot of lectures one can do. Like, say, for example, in geotechnical engineering, need for investigation of failures, Thursday lectures of Professor Leonard, Sowers. There are so many lectures that are available. You can read that. Then, because as I said, soil behavior is so complex, people should understand soil behavior. There are a lot of papers on basic physics problems, and there are a lot of work that is done on those lines. I can even this slide, I can give one more lecture on this, because I taught this course. Bearing capacity of shallow foundations. If there is a failure, what did it learn? People learn. People came up with the theories on how things can be avoided. Okay. There are a lot of failure theories on bearing capacity, shallow pile foundation, landslides, geo-environmental engineering, failures. There's so many things one can really do, and observational approach. Okay, data analytics nowadays is coming up so much, but in civil engineering we are not encouraging. So definitely it is an opportunity for us to really enforce the data analysis subject in engineering, like different types of design approaches. Like I want to say, the design safe approach. So there is a method called, even if it fails, consequences have to be minimum, like design safe or fail safe approach, they call it. Like, you know, the WTC tower in US, because of the fire, there is a collapse, inward collapse was there, rather than it getting fluid off somewhere and then attacking the other building, others didn't catch the fire, right? So the design safe approach one can come up. There are a lot of human factors in engineering failures, like in India particularly, because we want a lot of labor, but then they are not well trained. We want the same screwdriver for every small thing. We don't use proper engineering sometimes, with the result that there will be quality control issues. Importance of continuous education and training, like this is what we have a course here. Ethics are also very, very important. We don't have courses on ethics, right? In AICT, we don't have courses in some of these things. So a lot of issues are there. In forensics, a lot of journals are also there. One nice Journal of Performance of Constructive Facilities, ASC. Very nice journal, you can see that. Performance proceedings of institutional engineers, forensic journal is there. There are some papers and books and all of that. Okay. So this is what I want to say. Thank you very much. Thank you for your attention. So.
Thank you so much, sir. The session was wonderful, and the presentation was also very nice and very informative. So, any questions from participants?
Hello. Good afternoon, sir.
Yeah.
Hello, sir. First of all, a great session. Thank you so much for that. And the next is, I wanted to ask now, as we have discussed the methods of forensic engineering, like what are the steps that have been followed in forensic engineering? Is it possible, or can we say, is there any role of a forensic, let us say, forensic engineer before the execution, or before, like while doing the construction, or before that, before the execution? Can a forensic engineer play an important role, so that we need not to do forensic engineering after the failure or something like that?
Yeah, actually, in principle, no, forensic engineer come only after failure. But you know, there is nothing. It's actually, you know, we do a failure mode analysis. We don't call him as a forensic engineer, but a senior person, like what can go wrong, right? You can think of issues or what can go wrong. That you can list out and then look at all of those and then avoid failure. You know, that could be one thing. Yeah.
But then, yes.
Yeah.
Okay, but then we don't, and even after the forensic engineer as such, there is no thing. Only the experienced persons are there. They can, those who are having experience.
Yeah, not experience, understanding failure. They should have seen. Like I have seen, somebody will have 30 years of experience, but he doesn't anything. That we don't want that case. Yes, we don't want that. You know, somebody should have knowledge. They should have fundamental knowledge and they try to contribute, because this experience doesn't mean anything here. You know, for us, it's more about failures. So they should be able to give that insight. Yeah.
Yes.
He can be in the team, part of the team, so that we can understand what can be problems.
Thank you, sir. One more thing. When I'm thinking from the research point of view in forensic engineering, like, can we apply GIS technology in forensic engineering, something like that?
Yeah. So what I showed you was that, you know, hazard zonation. Say, for example, I showed you that a few districts, like, you know, hazard zonation.
Yes.
Landslides. It can be for anything, even including water supply. Okay.
Yes. Okay.
including anything you can do, no? Like the things are where things are not working, you have to identify, you have to zone them, you have to you have to project the intensity of problems and bring it to the. See, you and me cannot do anything. We can only analyze and then tell the severity of the issue.
Yes, correct.
Yeah.
And like now, while we are seeing about the landslides, is most this rainfall is rainfall the primary reason for the landslides, or like
No, see, rains will come. You know, rains will come. We can't stop them. See, that I don't feel our poor engineering is a problem, not our
Okay.
rainfall. Rain, we want rain. You know, we can't change climate change.
Yes, because
All that we can. No,
in the-
unfortunately, our engineering has to be good. Okay.
yes, because just now the heavy rains have happened in Konkan region, Maharashtra.
Yeah.
So was that are we do you have any idea about it, or have you gone?
I don't have any idea. I don't want to have any idea. This district administration, they should wonder.
Okay.
Like you take your help from GIS and
Okay.
if you are from Maharashtra, try to help them. You know,
Yes, yes, I am from
unfortunately,
Maharashtra.
yeah, I know. So that they have to handle this, you know, like Bangalore, Pune University or your Marathon, all you know, whatever. So
Yes.
otherwise, no use, right?
Yes, thank you so much, sir. That's all from my side. Thank you so much. Great session.
Okay, so any other question from any other participants? If you have, please ask. That one question, it is in chat box, somebody written. What has been feasibility of reinforced structure testing with respect to the unreinforced structure testing on centrifuges?
No, it's not required. Why? Because centrifuge is not meant for this. So you should have, you can take for a headache some stomachache tablet, right? So we should not do this because centrifuge is meant for, you know, you can do in one sense, but you know, the issue is that the centrifuge is meant for understanding the scale effects. Okay, like in IIT Bombay they have. And see, actually, we should avoid going to centrifuge. Why? Because that is not, you can't do this. It's actually, in my opinion, there is a simple commonsensical problem. We can solve it. You can do on your own, you know, simple pen and paper sitting on the table, whatever. See, what has been the feasibility reinforcement testing with respect to unidentified? Why you should do, we know fundamentals itself, no. Why you should go to centrifuge at all? This thing is all basically known. Isn't that? So otherwise you can do a beam testing in your own college and whatever you want to do. It's all well.
So any other questions from any other participants?
Yeah, questions are welcome because it's nice to see so many faculty here.
Yes, sir.
Because, yeah, one more question. My request is that don't be faculty, you know, you're engineers first. Actually, I have seen tired of the faculty are afraid of engineering. So that is other danger I see. That's you have to be good engineers.
Once again, I'll ask one more question, sir. It's like now, as we are seeing that forensic engineering is the developing branch in engineering. So, under civil engineering, do we have any courses that are available under forensic engineering, or can anybody look into it as a career point?
The career is there. See, most of the people, retired persons, I have seen a lot of chief engineers. Okay, they have been they didn't know anything. After they forgot civil engineering, and after 55, they become a law course. And after 55, they become enter into bar. They become, you know, advisors.
Okay.
They have that type of forensic engineers. I have seen many. Yeah, that you know they will be in senior positions. They would have seen a lot of failures.
Yes.
Then they get law degree. You know, you can go to any law nowadays. Like getting law online very easy. So they become forensic engineers and they argue in courts. It's a big money, actually. A lot of money. Very good side. Regular income. I have seen a lot of engineers here.
But then that will come. Even only after seeing a lot of failures only, right, sir?
No, engineering knowledge comes, but to become a foreign engineer, you know, what is happening? The problem is that good knowledge is required. Okay,
Yes.
That's very important, and you should practice forensic with good knowledge legally also. Because actually, I know one person from Mumbai. He was actually feeling very bad because some of the engineers are in jails.
Yes.
Why? Because here you see, okay, that road is not good, and okay, who that Jay was in charge, he was put into jail
Yes.
for 1 year. Nothing. It is not his fault.
Yes, contractors for it.
Yeah, it is somebody's fault. Why, they try to point out that they say who is helping. He was actually, I was very shocked to learn from him that many engineers are struggling in jails. They are not able to know how to handle, how to argue themselves,
Correct.
and how to bring out the even engineering, like say for example, arbitration, right? Arbitration. You will be seeing a lot of projects will go for arbitration. They also don't have. They will have all the arbitration department should have forensic engineering knowledge. Otherwise, how do you win an arbitration?
But then we can say this, that's basically loss of small colleges, because small college just teachers don't make their students aware of all these scenarios or the forthcoming problems that they are supposed to face. So maybe because of that, students
No,
are not
no, forensic engineering, it comes now only little later. See, at the BTech level, see, I have seen at BTech level, if they start forensics, I feel a little too uncomfortable because it is again a forensic failure.
Okay, yeah, okay.
Ah,
Yes,
like they're supposed to be a good engineer. Good engineer, you should be a good design engineer first.
yes,
Okay. Our objective should be as a teacher and all of that. We don't want to see failures. I don't want to make a career in forensics.
yes,
Is it not?
yes, yes, correct.
Like our doctors are very happy, right?
Yes, yes,
Actually,
correct.
ideally, we don't want doctors, right?
If you are
I should, yeah, we don't want doctors. Why should we want doctors? Like, in fact, I was in a conference on quality control, and not quality, NABL, okay? It's a doctors organized for doctors, because in quality control in medicine is very good,
yes,
right? You must have seen, right?
yes, yes,
The moment the corona came, nobody knew about corona 1.5 years back.
correct,
Now we have such an expertise, right?
correct.
I mean, we are excellent.
Yes,
That is because the labs have improved very well, profession has improved very well.
yes,
Yeah. But why roads are bad? Imagine. Then I told, I was participating in the same organization. There, it's a conference of all doctors, laboratories, technicians, and all of that. They're all working together to develop quality control. Okay. Now, we never had such programs in India,
yes,
in civil engineering. And second thing is, then I was asked to give a presentation. Then I had to tell them that if only good engineers are there in the country, you will not have practice at all for doctors. I have to tell them.
correct.
Because doctors have good business in whatever, every corner you have medical testing facilities and 5-star hospitals, because roads are bad or environment is bad, pollution everywhere, right? So I think we have to understand this properly. Yeah.
Yes. Thank you.
Okay, so any more question for sir? So now, sir, I think queries of all the participants have been addressed. So, sir, it is an honor and privilege for me to invite you to participate in the FDP as an expert speaker. Thank you so much, sir, for accepting the invitation. Thank you a lot.
Thank you.
So now, participants, now we will meet again at 3 p.m. for our next session, that is session 6. This will be on forensic analysis of groundwater contamination resulting from industries by Professor A.K. Kesari from IIT Delhi. So all the participants are requested to kindly assemble on this virtual platform for the session. So you are requested to join the session by using the same link 10 minutes before the session time. Thank you so much for your patience of listening. Thank you so much. You can leave now.